Students, I'll start with the class. This is a new chapter, this probability. So before starting with the probability, you need to know what is something called as a sample space. I hope you all are having the notes with you all. Okay. This is a sample space. So already the definition is given in the notes on page number 1. It is, so it's nothing but a set of, the sample space will always be written in form of a set like this. A set of all possible outcomes of a random experiment. Means what? Any experiment you are trying, okay, it will always have some result. There could be many possibilities. Just for example, if you are throwing or tossing a coin means you are throwing a coin. So that if you throw, there will be two possibilities. Either the result will be what? Head or tail. Okay. So when you toss a coin, either you will get head or tail. So a set of all the possibilities of a coin when you throw a coin, so that is called as a sample space. So what was the experiment? The experiment was throwing a coin or tossing a coin, and this is the result. So usually denoted by, instead of writing sample space all the time, this is indicated as S, and N of S will be what? The number of elements in that. Number of elements in the sample space. So how much it will be? Now right now there are 2 elements. So N of S will be 2. So this is the basic definition. Okay, so now we'll do some this exercise. Find a sample space for the following experiments. So all these are 10 experiments. So we have to find sample space for that. So starting with the first question. Question number 1. You have to find sample space for tossing of a coin, which I've already done here. So we'll anyways write again. So when you toss a single coin, what will be the outcome? Head or tail. Only this much you have to write. So this is the sample space for first one. If anyone is having doubt, you can ask her. Second one, tossing of 2 coins simultaneously. Okay, sometimes they'll mention like this, tossing of 2 coins simultaneously, or tossing of a coin twice, 2 times. Okay, the same coin if you are tossing 2 times. So in both the cases, the meaning remains the same. Okay, so 2 ways the question can come, either tossing of 2 coins simultaneously or tossing of a coin twice. Answer will be the same. So whenever you're tossing 2 coins, okay, so that will be the head. This can come option, okay, or head, and this fellow can be tail, or the first coin can have tail, the other one can have head, or both can have tail. So these are all the possible combinations if you are throwing 2 coins. Okay, either both can have head or one of them, this tail, this head, or both can have tail. So your sample space will be head, head. Now it will come as 2, okay, together. The head can come because these are 2 coins, the first and the second. Head, tail, tail, head, doesn't matter whichever order you write first. Even this element can come here, this can go there. This is the sample space for 2 coins. So when one coin is tossed, either it could be head or tail. When 2 coins are tossed, it could be head, 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 tail. Okay. Now third one, when 3 coins are tossed. When 3 coins are tossed, it could be all could be head. Okay, now there's one easy way out. Okay, instead of trying all the methods now, I'll tell you a shortcut to give you all the combinations. What you do is, see, when this was only one coin, you had two outcomes, correct? N of s was 2. When n of s was 4 elements will get. And when this is there, here you will always get 8 elements because it is 2 raised to n formula if you want to remember. Okay, so this for the first one it is what? 1 coin means 2 raised to 1 will be 2. If you have 2 coins, your outcomes will be 4. If you have 3 coins, 2 raised to 3 is not 6, will be 8. 2 cube, 2 into 2 into 2. So you know that you need 8 outcomes, 8 possibilities over here. So it's like trying like this: head, head, tail, then head, tail, head, like that. So instead of wasting time in checking whether you have not missed out anything, what you do is, this is one trick which I normally follow. 8 outcomes you need now total over here. So what you do, first write 4 heads straight away like this, and then write 4 tails. Okay, write 4 heads and then write 4 tails. Then next will be 2 heads and 2 tails. Again 2 heads and 2 tails. First time 4 and 4, then 2 each, and the last one 1 each. Head, tail, alternate. You will get all the possible combinations. Okay, just try it one time. Here 4 and 4, then 2 and 2, then 1 1 each. Alternate. So these are the possibilities which can come on a 3 coins. On the 3 coins, head, 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 or it could be head, head, tail. It could be head, head, tail, head. If you notice, all these combinations are different from each other. No same combination is there in that set. Okay, everything is different. Every combination is different from the other one. So these are the possibilities. So we have to write it in the sample space form. Head, head, head. This is one option, one possibility. Then just copy this here again. This is your answer. We just want to know how much is your sample. This will be 8. Number of elements. So this has to be counted as one element. This will be your third answer. Although I have not given 4, means when you toss 4 coins, I'll just do it. Okay, just don't write a question number for that word because you will miss out the remaining question. You can just say 3A and you can just add a question 3B, tossing of 4 coins. Usually they don't ask, so I am not given. But if you want to understand how it works, I'll just explain. 4 coins means use the formula. How many possibilities for this? I told you this is the formula. That will be 2 raised to 4. So 16 possible combinations. So sitting and thinking which could be the 16 combinations, it's like head, 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 and head, head, head. 16 half is what? 8. So how you'll write? First write 8h. How we had 4 and 4 no? Which was half of 8. Like that we'll have half of 16. So 8 heads. 1, 2, 3, 4, 5, 6, 7, 8. And then 8 tails. then 4 each. 4 heads, 4 tails. 4 heads, 4 tails. Then 2 heads. After 4, you have to just go on making half. 2 tails. And last, single. Without even using your brain, trying to think so much and wasting time, what could be the next possible combination? You'll get all the 16. Every combination will be different from the other. So these are all the different possible combinations which can come on the 4 coins. And if you want to write it as sample space, then you'll have to write like this entire. If anyone is having doubt, the tossing of the coin sample space, you can ask. Okay, so if this is done, then we'll move on to the fourth question. Fourth question is rolling of a die. One, okay, rolling of a die. So one die, if you are throwing, it is called a die, and like if plural form, it is called die. Dice is the one which you play snake and ladder or ludo. So obviously, when you roll a die, which all numbers can come up on the die, that will be a sample space. So fourth one is you have to write a sample space for rolling a die. Whenever you roll, which all possible combinations it can have, either one number can come up, 2, 3, 4, 5. So this is called sample space for a die. Okay. The fifth one, when rolling of 2 dice. Now 2 dice, here it's a little bit lengthy one. What all combinations can come? There are 2 separate dice now. You have thrown 2 dice. So any possible numbers combinations can come. Suppose if this can come as 1, this could come as 5, 6, anything. So you have to try all the possible combinations. So in that case, how you have to write is, you have to put a bracket like this. This is for the first try. What all combinations? Both can have 1, 1. Okay, both dice can show 1 or it. Okay, we'll go on trying the combinations. Keep this fellow fixed only till you get all the numbers. So 1, 3 it could have 1, 5 or 1, don't stop because it's still not over, because this is only with one layer. So keep this one fixed, try all the different numbers. Then what if the first die is showing 2? So it could have 2, 1, 2, 2, 2, 3. This also could be the possible combination on 2 dice. This is for the first die. Okay, for the second one. It has all the numbers you'll have to try till this fellow also reaches 6. Five comma 1. So you have to stop here because both have reached 6 comma 6. You cannot try with 7 comma 1 and 1 because there is no 7 on a die. So total how much combinations you'll get? 6 into 6, 36 combinations for 2 dice. The n of s is 36 for this number of elements. So this together itself can put a comma between each of them after every element. Put a comma for every given thing. So all the 36 combinations can come if you throw 2 dice. Then the sixth one, the sixth question is from a group of 2 boys, 3 girls, 2 children are selected. So find a sample space, means what are the possible combinations which can be taken out. So when you have to write sample space, you cannot simply write a number. Actually, if you use a combination problem, you know that out of 5 students or 5 children, you are taking out 2. If you calculate 5 factorial upon, that will turn out to be 10. There are 10 possible combinations. So anyways, that this is not a correct option, the means answer, even though this is not the way to write. Whenever they ask sample space, means you have to describe the combination. So what you'll do is, so let the boys be B1 and boy 1, boy 2. Same way, girl 1. You have to assume like, so now which all combinations will be there. Just we start with the first one, pair it with any of the possible combinations. So 2 students are children are taken out, so it could be boy 1, boy 2, or boy 1, girl 1. First one only you keep it fixed and try with other till all of done. Okay, so we are done with boy 1. Then move on to the boy 2. Boy 2 and boy 1 is already done, so no need to write again. This combination is already written, so don't go back. This then done with boy 2, then girl. girl 1, girl 2, girl 1, girl 3, girl 2, and girl 3. Last. So to count, you'll get 10 combinations. There's no point writing again ulta girl 2 and girl 1. They are not asking you to sit and arrange. They are only asking what could be the possibilities. Which two girls have been selected. They have not asked in which order and all. Which two children are selected. So even if this is written ulta, doesn't matter among itself. As long as boy 1, boy 2 is selected, boy 1, girl 1. So this is the sample space for your sixth question. Seventh question. A coin is tossed. Okay. So you know that whenever a coin is tossed, what is the combination you can get? Head or tail. Okay. So whenever you're tossing a coin, what can come up? Head or tail. Now, if it shows a head, means there's something else what we are doing. After head, if you get a head, means you have to do this next experiment. So if it shows a head, you have to draw a ball from the bag, which consists of two red, means you can name it straight away as R1, R2, and three black balls, B1, B2, two red, three black balls. So we have to pick a ball, one ball from here. So if it shows a head, we draw a ball from the bag consisting of two red and three black balls. Now if it is over, so this experiment. Now if it shows a tail, we throw a die. So whenever you throw a die, what I told you is the sample space for a die. What all can be there on the sample space? All the numbers till 6. This is for the die. So now we have to write the sample space. What it means is if you are getting a head and you're picking a ball, what all could be the answer? Either you can get head if you are getting, and then if you are removing this ball out, it could be this, or it could be this. Okay, any of this could have been the combination. Same way, if you're having a tail, either you can get 1, 2, 3, 4, 5. Your sample space could be, suppose if you are getting the first one is head. Okay, if this you got a head, then you are picking a ball. So what all could be there? So if you got a head, first option could be R1. Again, if you are getting a head, second combination could be R2, or head and R3. Sorry, B1, then head comma B2. This is comma, not H1. This is one. Then H comma B3. Don't close the bracket here. This is only if this head had come up, this could have been your answer. But if tail comes, what will be answer? Tail comma 1, tail comma 2, or tail and 3. This will be a sample space. If anyone has not understood, can ask. Eighth one. A bag contains 3 blue, 2 red balls. If 2 balls are drawn from a bag at a time, find a sample space. So this could be, you just name them as B1, B2, B3, red one. Same like that. Question number 7, this is, sorry, question number 6, like boys and girls. So two combinations you have to pick. Which could be the 2 combinations? You can start with this, pair it with everyone. Then start with B2, pair it with everyone. B1 R1, then in B2, B3, B3 R2, then R1 R2. Okay, last it is done. R2 again you cannot come back because R2 B1 is already written. Yeah. If you want, you can put bracket also. Just here, if a teacher is asking you to put bracket, you can do this way also. Even if you don't put bracket, it's still fine, huh? No problem. Then question number 9. An experiment consists of rolling of a die. Now you are rolling a die. And then what you do is you have to toss a coin one time. If the number on the die is even, so what is they are trying to say is you have to throw a die. Now you have to check whether the number on the die is odd or even. So if it is even, then you have to do the second experiment. That is what you have to throw a coin. Now, if the number is odd, then what you have to do? Instead of throwing it one time coin, you have to throw 2 times again. So it means like this. So throwing of a die will be what? Either you'll get even number or odd number. I'll just write it separately so that it becomes easy to connect. So it could be 1, 3, 5 or 2, 4 and 6. So this could be a possible combinations of on the die. So odd I'm writing separate. If this turns out to be odd, and let's see if this turns out to be even, what to. Now what you are doing, if this turns out to be odd, then what so consider you got 1 now. You threw a die and you got 1. So what they have told, if you get an odd number, you have to throw the coin 2 times. 2 times means what? What all could be again the combinations? Head, head, okay, or it could be head, tail, it could be tail, head, or tail, head. So 2 coins if you are throwing, this can be the combination. So if you got an odd number and if you are throwing coin 2 times, this possibility can come. Same way for this also. If you are getting 3 and then again if you are tossing the coin, so this will be the same thing which will come up. One of this will appear. Same for this one. If odd numbers come, this could be the combination for the next experiment. Now, if there's an even number, what you have to do, just throw a coin once. One time if you are throwing, what are the combinations? Either you will get head or you will get tail. Same way, this is also even number. Only one time you'll have to toss. This will be your next outcome. Either head, tail or head, whichever. So write it in sample space form. Means what? If you are getting odd number, means you'll throw a coin. So what are the combinations? You'll have to write every arrow you have to find. Or it could be 1, or this could have come up. Or this, or the fourth. So these are the possibilities if you get 1 on the dice. Now, if you are getting 3 also, will be same. 3 comma head, head. Same way 5 comma. Then yeah, 2 if you got, what could be the next combination? The next, this is always the second experiment, what is they trying to say. So first one if you had got 2, second one you can get tail, head, or you can get tail. Same way if you had got 4, head or tail. 6 comma head or 6 comma tail. So this is a sample. If you are finished, you can try the next one. 10th one. 10th one. Now 2 coins are tossed. So 2 coins are tossed means what all combination? Head, head, tail. This could be a first experiment outcome. Now, if the second outcome means what? Second outcome means second coin. So just write there. If your second outcome means second coin, this is the first outcome, this is the second outcome. The second, if the second coin results in a head, then a die is rolled. Okay. So now you have thrown this. Consider you got this combination on the 2 coins. Okay, this and this. Means the second outcome is a head. So obviously you have to do the second experiment now. So means you have to roll a die. So if you are rolling a die, what could be the combinations? 3, 4, 5. So then either one can come up, two can come up. Here, what is the second outcome? Tail. I don't have to do anything. Just leave it here. Now, if this is the combination, means the second outcome is a head. So now I have to do another experiment. That is again roller die. So what can come up? 4, 5. Just nothing to. Now write the sample space. If they had said second result is a tail and then do something, then even this would have error. But now nothing they have mentioned. So now I'll write sample space. So if you are getting head in the first experiment, what can come up? 1. Same way h comma 2, head comma 3. Okay. Then you have to write this also. This you write single only because there's nothing to pair with the second experiment. So you can keep like this. Then comma. Then tail head comma 4. Okay. And last one, the end. Any doubts in finding the sample space? Anyone? Okay. Now next is something called as event. What we had studied till now is called sample space. Next term what we'll know is what is called as an event. Event is nothing but a subset of the sample space. Subset means you know that smaller set of sample space. Sample space means all the possible conditions. This will be event is nothing but a condition. So this will be with some conditions. So now consider, I've given one example in the notes. Example says, let us consider one experiment in general. So what does the experiment say? 2 coins have been tossed. So in general, without any condition, first thing what you need to know is the sample space. So the sample space will be what? Head for 2 coins, head tail, tail head, tail. No need to write, it's there in the note. Okay, so that is the sample space. Now, what is the event? Event could be many things. Okay, it's not a fixed event. You can also make up an event. Any condition you can put, so that is called as an event. So one example of event is, so you have to write only that this which satisfies this condition. The description of an event is, the event says there has to be exactly 2 tails out of this. So you have to write only that. So event 1 you can consider A. So what does the A say? That both the coins have to be tails. Exactly 2 tails I should have. So where is exactly 2 tails? Over here. Only this will be my subset. So this is an example of a event. It becomes a smaller part of it. It can be full also or small also, but with a condition. So second condition, this you can simply create your own. So at least one head should be there. At least one head means minimum one head should be there in that. In this, there is minimum, there are 2 heads. So it is satisfying the condition. At least one means minimum one. So of course, 2 are there. Still it will work. Here, they have not said exactly one. Huh? If it they had said exactly one head should be there, then you cannot write this. So this has 2. Now they're saying at least one. So there. Here also at least one head is there. Here also there is at least one. In this, there is no head, so you cannot write that. So these are the 2 examples. Like that, I can make any kind of event, put any condition. Like event C could be, first one should be head. First coin should show head. Then what you'll write? Only these 2 answers. Wherever first coin is showing head. So this is the definition of event. Now there are different types of events. First one is the impossible event. Impossible means whatever condition is there, they are putting, it is doesn't exist only in the sample space. Since I've given one example, see, rolling a die. So when you roll a die, the sample space is this. Now what is the event they are asking you to find? Event, let E1 be the event where the number appears on the die is 8. So is there actually there's a number 8 on this? In the sample space? No, doesn't exist that condition. So that's why E1 will be empty. Or you can write it as 5. So it's an impossible event. It is not possible to have a number 8 on the die. Next, second one is a sure event. Sure event means will be the whole sample space. Everything of the sample space will appear. Okay, there will be no element missed out. The experiment same remains. Okay, I'm taking the same experiment, throwing of a die. Throwing of a die experiment is sample space is this. Now let me consider E2. So from here, refer the sample space and write only those elements which they say no the number. Okay, it's not the number which appears on the die is less than 7. So just correct it if you don't get confused. Number on the die should be less than 7. They're asking you for those elements from S which are satisfying this condition. If you notice, all the numbers are less than 7. The E2 will be. So is it the whole sample space? Yes, every element is there. Not even one element is missed out. Okay. So if every element comes into the event equal set, then it is called as a sure event. So E2 is equal to S, the sample space. And the next page, page number 2. Simple event. Simple event means it has only one element. Simple element will have only one element. So let us consider the experiment of tossing 2 coins. So experiment is sample of tossing 2 coins. So that will be head, tail, head. So this is an experiment. Now we'll consider event. So E3, let E3 what they are saying, we find out only those elements on which the tail occurs on both the coins. So which is the element? Only rest all is having head, but they want only that element which has tail on both the coins. And this has to be considered as only one element. Comma is separated by just one. So how many elements are there in E3? Even though there are 2 letters, but the element is considered as one. That's why it will call as simple event. Then the fourth one, that's a compound event. Obviously, more than one element. The same sample experiment, sample space will be same. So tossing of 2 coins. So E4, what they are saying, it should have at least one tail. So which all are having at least one tail? All these 3. This one is not considered. It should have minimum one tail. So E4 will be. How many elements are there? 3 elements. Obviously more than one. So that's why it is called as a compound. Even if there were 2 elements, still it would be a compound. So anything more than one is called compound. Next is the algebra of events. So means in terms of sets, we can always relate to this sample space and the events. Okay, sets and this chapter is related, and even combinations and permutations will come under this chapter. So you need to know all the chapters properly. Now, complement of A or not A. The event A means if this A is the event and you want to find complement or not of A, how it is described as A bar or like this also. Whenever they say A or B, or means always I have told you, or even this at least one, if they say this is all done under sets actually, just a revision like, or means always union. And means both A and B means intersection you have to find. This is all given in the notes. I'm not writing anything. Then fourth one, only A means what? I want A, but I don't want B. I want only purely A. So you have to minus this. A minus B. I have to remove out B because I want only A. Same way, B but not A. So you'll have to remove out A. B minus B. And the last one, neither A nor B, or also called as none of the elements or none of the events. Both will have a bar on top. A bar intersection B bar. So this is also called as S minus sample space. From the whole sample space, you have to. This is also like a formula. A bar complement intersection B bar is equal to S minus A union B. Why I did this algebra, so that you understand the next one, what is called as a mutually exclusive or disjoint event. So that term, that's an important term. So called as disjoint event. Disjoint means definitely from the term itself you understand. Disjoint means there is no connection between them. Okay, they are all separate. They are also called as mutually exclusive. So when they are called disjoint or mutually exclusive, when they have no connection between them, which is also meant by they have nothing in common. It's an empty set. Intersection means no common element. This this happens when they have something in common between them. Okay, and disjoint events will be when they have nothing in common. This ones and this ones have nothing in common. So they will be separate. So this will be disjoint, or also called as mutually exclusive. Intersection is an empty set. So I have given you an example. Suppose if the sample space is or directly, if A is 1, 2 and B is 4, 6. So I want to check whether they are mutually exclusive or disjoint event. Okay, whether it is mutually exclusive. So how to check? You have to check whether anything is common between them. Is there anything common element? No, nothing is common. It's empty. No element is common between A and B. So that's why they're called mutually exclusive. And the last one, exhaustive. Exhaustive events. Means that was what? Related to intersection. Mutually exclusive was what? With intersection, and this is related to union. So if you combine two sets together now, okay, and if it is turning out to be the same, like a sure event, okay, sure event means what? The whole sample space. So if A union B is equal to the whole sample space, then it is called, then those two events are called exhaustive events. So give an example. Same thing. Sample space is 1, 2, 3, 4, 5, and 6. A is 1, 2. B is suppose. So they are like this. It is given suppose, and you are told to find out whether they are exhaustive. So to find if they are exhaustive, always find a union, not the intersection. They ask to find whether they are disjoint, then you have to find intersection. But for exhaustive, you have to find union. Union means put all the elements together, and if any element is repeating, don't write it again. So 1, 2, 1 is already written here, so no need to write. 4, 5, 6, and 3. So are the same events there? Yes, all there. All the elements are there. So exactly it is equal A union B is equal to your sample space. So that's why they're called as exhaustive events. Even if one element is missing, then they are not exclusive, then it is not equal to. So based on this, now let us solve some problem. Exercise 2, first question. In a single throw of die, single throw, okay, single throw means just one time the die has been thrown. So what are the possible combinations? Sample space. Okay, anytime like this is given, write the sample space first. So single throw of a die, you throw a die. So what all are your guesses which can come with this? You can guess the numbers. So that will be 1, 2, 4, 5. So these are the possible outcomes. That's a sample space S without any condition. Now they are asking you to create these events. So now these sub questions 1, 2, 3, 4, 5, 6. So they are all events. So they have also asked in the question itself in a single throw of die. Describe means find the following events. Describe also says you have to find it. The first one says getting a number less than 7. So you have to always refer the sample space. So what is it? Getting a number less than 7 means all the numbers which are less than 7 you'll have to write for A. Actually all of, so this will be your first one. Then second sub question says getting a number greater than 7. Check over here. Is there any number greater than 7? No. So B will be empty. Then third one says getting a number, also getting a multiple of 3. So you have to always refer this fixed one, don't refer anything in between. Sample space. So check in the sample space any multiple of 3. So it is 3 and 6. So the answer will be 3, 6. So we have to be careful with your sample space itself. This sample space only you are writing wrong, all these events will go wrong. Huh? Then the fourth one, getting a number less than 4. Less than 4. They have not said equal to 4. Huh? Less than 4 will be only this. Then fifth one. Can anyone tell me the fifth answer? Fifth answer, anyone? Check for a even number in that sample space which is greater than 4. Everybody is so lazy to even unmute, even though I know you all know the answer. Yes, 6. Someone or someone will answer that you all know. You all just wait till somebody answers. Even if you know, this will be E. Then sixth one, getting a number not less than 3. Not less than 3 means I don't want this which are less than 3. It could be equal to 3 or more. As long as they are not less than 3, you can write down. 2, 3, 4, 5, and so based on this, they asked you to find some sets. This is same. Okay, this is very simple. Now, as long as you get these sets, this is common with the sets chapter. So A1, you have to find A union B. This everyone must be clear by now. A union B. So you have to combine this. Combine means you have to anyways, like it's like adding 0 to this. 1, 2, 3, 4, 5, 6. Don't write like this and keep on. That will be wrong. It was equivalent of having like this empty space. B is like this. We are not adding anything. So A union B will be this answer. Then B part, A union B union D. So add all this. Because D anyways, they are the same repeating element. So no need to write again. Then third C part is B intersection C. Means what? Intersection now means what is common between. Is there anything common? No. So that will be also empty. Then D, E intersection F. What is common? Intersection is common. E and F, 6 is common. A bar. A bar means you have to refer your sample space. This is like a universal set. Okay. Anything other than this. A complement means you have to refer your sample space. Any other element if it is left without that. But go to see all the elements are in the sample space. A complement, if you minus all the elements from here, it will be nothing will be remaining. This will be empty. A complement. Suppose consider if A was of this, then you have to compare with this. Other than this, if any element is left in the sample space, that answer you have to write. So answer would have been 6. But now all the elements are already there. So if you are minusing all, nothing will be left. So that's why it will be empty complement. Just write, make it as F instead of G. E bar union F bar. So first find E bar. E bar means E, you have to compare with your sample space. Other than what is there in this, only don't write that. Remaining everything you'll have to write. E bar means other than 6, what all elements are. Then F bar. F bar means other than these elements. So cancel 3, 4, 5 and 6. So what is left? Sorry, from the sample space. Huh? So what is left? 1 and 2. And then combine these two. Union means you have to combine E bar and F bar. So what will be answer? 1, 2, 3, 4, 5. Okay. So E bar union F bar is 1, 2, 3, 4 and 5 after combining these elements. This I'm not stressing so much because that's the same thing from your stats chapter. Now question 2. A coin is tossed 3 times. So 3 times means how many events will be there? 8. 3 coins, that one. So I told you how to quickly frame it. Head, 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 tail, tail, tail. Like this. Then head, head, tail, tail, head, tail, head, tail. Like this. Quickly you have to do this at the side. Okay. And then write the sample space. So head, head, head. If anybody still doesn't know how to find this, can ask again. Huh? Otherwise, there's no point by hearting all this. This is a sample space. So whenever you're tossing 3 coins or a coin is tossed thrice, it means the same. This will be a sample space. Now we'll make the events out of the sample space. The first event says no head appears. So they write only those elements where there is no head, not even on a single coin. So only this is the one where there is no head. Then what is B? Exactly one head appears. So write only those combinations where there is only one head in that. Over here there are 3 heads. You cannot take this. Here there are 2 heads. No. So exactly one head. No. This one. Right? This is event B. Then C. At least 2 head appears. At least means minimum 2. What it means? 2 or more. Even more than 2 is okay. So minimum there should be 2. So this will not be there. Meaning there are 3. So of course it is satisfying the condition that it has to be more than. This also 2. This is not valid because it has only 1. Criteria is minimum 2. This 1. No. This also you cannot write. So this 4. Then D1, at the most one head appears. So those who had attended previous class on combinations will know this. Whenever I said at the most you can carry something, some luggage or something at the airport, doesn't mean that you can take, means if you take 0, it will be thrown out. You can even take 0. So whenever the word at the most is there, you have to always start with 0 and go on increasing. At the most one head means 0 or 1. So it should be less than 1. So if 0 is also less than 1. So 0 head or 1 head. So check whether there are 0 heads or 1 head. Those combinations. So your D answer will be 1 head, 1 head and 0. 0 heads away. Do they form exhaustive events? Exhaustive means we have to combine all A, B, C and D. Exhaustive means I told you, you have to find union. So are these events forming exhaustive events? So union you find and check if it is equal to your sample space back. So this is A. Then combine B. Then combine C. What was C? Where it was? C was at least 2 heads should appear. If the same thing is repeated, don't write it again. Huh? So this was C and D part was here. So already this is written, no, HTT. THH is also written. Then THT is also written. ETH is also there. ET is also there. So all the elements are there if you notice. So it's equal to your sample space. Therefore, they are mutual. They are exhaustive. So this whole thing is equal to your sample space. Order will not matter as long as all the elements are there. Then third one, an experiment involves rolling a pair of dice. Describe the events. pair of dice. Pair of dice means the sample space. If you want, you write, otherwise you can refer already which is written. Okay, so I'll quickly write here. You can leave some space for that and write again later, or you can refer from your previous, on the first page it is there. So, okay, you can write quickly. So this will be a sample space for 2 dice. So this is your sample space. Very simple. You have to start with 1 and give all the combinations of other numbers. Then start with 2, again 1, 2, 3, 4, 5, 6, and just repeat till you reach 6, 6. So that's the sample space. So rolling a pair of dice, huh? Pair of dice means 2 dice. Those who don't know. That's why it is like this. So now we'll describe the events. Even number on the first die. Write those events only where there is an even number on the first die. So which is the line? This line. Even number on the first. This. We'll have to write these 3 lines. You cannot take this because this has odd number on the first die every. So that's a event A. Anyone who did not understand? Only those pairs you have to write where there's a even number on the first dice, not on the second. No? Since doesn't matter whatever is there on the second, there's condition only given on the first one. Second could be odd, even, we don't care. Then B says what? Odd number should be there on the first line. Now the remaining lines you have to write. Odd means this. Okay. So A and B is done. C should be, the sum should be 7, at least 7, okay? Minimum 7 or it could be more. And then it should be a multiple of 3. There are 2 conditions. First of all, the first condition should be the sum. Sum means what? Whenever this, the moment you hear this word, read this word sum, you have to add this up and see. So only take those pairs after adding which becomes 7 or more. Right now, which are the ones? So 1 plus 1 is giving me 2, of course less than 7. Like this, if you go on adding, at least 7. So this is giving me 7. This is also, okay, 7. This is giving 8. Doesn't matter because some minimum should be 7 or more. So this is my first condition. So these are the pairs which is giving me a sum of 7 or more. And now in these pairs again, what we have to check, that sum should be a multiple of 3. You don't underline that. This is only for understanding at the, because now, so 7 or more, if it is there, what could be the sum? 7, 8, 9, 10, 11 and 12. 12 is the maximum possible sum over here. There is no number which if you add will give you 13, because maximum number on the dice is 6. If you add, it will be 12. So this could be the sum. So which are the number which are multiples of 3? 9 and 12. So check for those numbers which is giving you sum of 9 or 12. So now this part, this or everything will go. Only 9 which is given and 12. 9. Why? Because they are strictly saying it should be a multiple of 3. And 12. This is also there. So C answer is this. 1, 2, 3, 4, 5 and okay. And now we have to check whether straight true or false. Sorry, that is not the one. If the following events are mutually exclusive. Of course, A and B, just check A, first one, I have to check mutually exclusive. Is there any pair which is common? No, nothing is common. This is 2 comma 1, there will be no 2 comma 1 here. Same way, there is no 2 comma 2. Nothing common between A and B. No pair is same. Don't compare ulta ones. Don't say 2 comma 1 is same as 1 comma 2. Should be the same order. So definitely, therefore, mutually exclusive. B and C, B and C, no. These are the elements which are there, no? 5 comma 4 is there. 3 comma 6 is there. Okay, these two are there. So not equal to empty. It should have been empty. So not mutually exclusive. And the last one, third one, A intersection. What is common? 4 and 5 is common. 6 and 3 is common. 6 and 6 is common. Of course, it is not empty. So not mutually. Okay. Any doubt? Yeah. Enough. I'll stop here. Tomorrow I'll take a class. Okay. That time I'll continue with the question. Yeah.